4, day 10 notes. It's all about the number E. So let's talk about that number E. If you type E into your calculator, right, you will get the number about 2.71828, and it goes on. It actually goes on forever and doesn't repeat. It's kind of like the number pi in that aspect, that it goes on forever and it's not repeating. So since it does that, we say that E is an irrational number. Basically, a rational number could be written as a ratio, all right, as a fraction. You really cannot write E as a fraction. All right, a fraction like 1/3, if you typed 1/3 into a calculator, you'd get 0.33333 repeating. All right, something that repeats can be written as a ratio, or a fraction is a rational number. Something that goes on forever and doesn't repeat is considered an irrational number. If you ever forget what E is, you can just type it in on your calculator and it'll give you what number it is. So I'll show you that next. So on your calculator, E is the division symbol. You can press second divide to get an E, and then you can press enter so you can see that specific number. Functions. It says to graph y equals e to the x, y equals 2 to the x, and y equals 3 to the x. All right. What you want to think is that these are all exponential functions. All right. Remember, exponential functions can be written in that form: y equals a times b to the x. All right, where a is the y-intercept and b determines growth or decay. Right? If b is bigger than 1, your graph is going to be growing. If b is between 0 and 1, it'll be decaying. So I would do a little bit of rewriting here. It looks like all of these functions, e to the x, 2x, and 3 to the x, they all have that b to the x part, but they really don't have an a in front. They're missing that. So think about what number could you put in front that it wouldn't change the value of the function. And it's going to be a 1. It's going to be 1 times e to the x, and 1 times 2 to the x, and 1 times 3 to the x. All right, so they all have a y-intercept of 1. All right, so if we were graphing this and you go up 1, they're all going to have a y-intercept of 1. Similarly, they all have the same horizontal asymptote. All right, this plus 0, you could put a plus 0 on the end. Remember that number added onto the end? That's your horizontal asymptote. So we're going to have a horizontal asymptote, right, at y equals 0. All right, and then we need to draw these, and they need to be somewhat accurate in comparison to each other. All right, so the 3 versus the 2, the 3 is a bigger number. That's going to be growing faster. All right, so the 3 to the x is going to end up higher than the other graph, 2 to the x. All right, and then think about e to the x. All right, we just said e is like the number 2.71828. All right, so that actually falls in the middle of our 2 and 3. All right, so we need to draw these. We're going to have 3 graphs. All right, I'm going to try to color code them. Let's do the 2 to the x first. All right, if we drew the 2 to the x, maybe make it something wide like that. All right, that one's growing the slowest. All right, because its base is 2. All right, if we drew another graph, y equals 3 to the x. All right, 3 is bigger than 2, so 3 is going to go faster. So have it start a little bit below, and then it's going to shoot way up, right? And it's going to grow faster. All right, where the last one, the y equals e to the x, e is this number right here, 2.71. That's in between 2 and 3, so that one's going to start in between and end in between. It's probably a good idea to label these. This would be our e to the x. Right? Our 3 to the x is the highest. That's growing the fastest. All right, and the 2 to the x is the lowest. That's growing the slowest. Let's talk about compounded continuously. It has to do with interest. We recently talked about, annual interest, when you get the interest once a year. All right, Sometimes your interest can be compounded quarterly or monthly. Quarterly would be 4 times a year. Monthly would be 12 times a year. All right. Compounded continuously is basically if you get that interest over and over again. There's a special formula for it. All right. It's called A equals PERT. All right. So the P comes first times the number E, and it's raised to the RT power. All right. So let's talk about what all these letters are. P stands for the principal amount of money, or in other words, your initial investment. So if you're, initially investing $1,000 in a bank account, that would be the initial amount of money. All right. E, that's the number E. It's not an actual letter. It's not a variable. All right. So we said if you plug that into your calculator, you get 2.71828. All right. R is your interest rate. And just like those other interest problems that we did, all right, that always needs to be in decimal form if you're plugging it into a calculator. All right, normally interest rate is given as a percent. It needs to be given as a decimal. All right, and then T is going to be the number of years you plan on leaving your money in the bank for. Invest 12% annual interest rate for 1 year. What is the account balance if it's compounded quarterly and continuously? All right, so this is a little bit of old material, a little bit of new material. All right, when they say compounded continuously, that's that new formula we just talked about. That formula is going to be your A equals PERT. All right, but compounded quarterly is 4 times a year. All right, that was that Y equals A 1 plus R over N to the NX power. So we have different formulas, and you just have to remember these formulas. All right, so Dan invests $100 initially. All right, so that's going to be our A value here. 1 plus our R value, 12% annual interest rate. R would be 0.12 if you turned it to a decimal. Divided by N. N is, since it's compounded quarterly. Quarterly happens 4 times a year, so N is 4. Again, this is 4. And X, remember, was the number of years we're leaving this money in the bank for 1 year, so 1 year. Right? Remember what they're advertising? Just some vocab review here. 12% annual interest rate. We call that the nominal rate. All right. What they're advertising. Sometimes you might get a little bit more than 12%. All right. If you want to know the actual number that you're getting, all right, what you can do is just type all, just type all of this into your calculator and kind of look at the decimal version of that. So leave the 100 out for a second. We can deal with that later. All right, but if you just type that part in, and again, be careful with parentheses, especially if you have an old calculator. 1 plus parentheses 0.12 divided by 4 raised to the 4 times 1 power. You should get 1.1255 if you round to 4 decimal places. All right, and we said you can basically just look at the decimal part of that. If you turn that into a percent, all right, that means 12.55%. All right, that would be considered our effective annual yield. All right, that's what you're actually getting. Again, they advertise 12%, all right, for 1 year. Really what you're getting in 1 year is 12.55%. And the reason for the extra is because the interest is compounded quarterly. If you get that interest 4 times a year, you're going to get a little bit more than 12. All right, but if we want to know what the account balance is, we have to finish the problem, actually multiply those out. 100 times 1.1255. You get about 112.55. Right, so not a bad deal. Dan investing is $100 for a year. He made $12.55 extra. All right, let's look at part B, compounded continuously. All right, for A equals PERT, we said P is the principal amount of money, what you're starting with. That's your $100. E is just the number E. R is 0.12. And we said T is time in years. So same thing. If you wanted to see what your effective annual yield was, leave the 100 out of it. All right, type just this part into your calculator, which is really just e to the 0.12 power. You get 1.1275. All right, and you can just look at this decimal place. 2.75%, that would be your effective annual yield, what you're actually getting here. So it's just nice to compare. You know, you can see, all right, which is going to be the better deal. 12.75% is better, which we can confirm if we carry out the rest of the math, all right, and multiply that number by 100. We're going to get 112.75. All right, so compounded continuously was a better option, not by much. All right, got you about 20 cents more, but it was a little bit of a better deal. Let's take a look at example 2. It says, give the continuous growth rate of each function and graph each function. All right, so we were talking about compounded continuously today. All right, anytime you see that word continuous, all right, we're talking about that A equals PERT formula. All right, you're never going to use that formula if you don't see the word continuous. All right, so if they want the continuous growth rate, they just want that R value. All right, so if you look, all right, this formula, even though the letters might be a tiny bit different, all right, I think it is written in that form A equals PERT. All right, so the R value is this 0.02. And so R is 0.02. All right, if we turn that to a percent, all right, 2% is our continuous growth rate. All right, so that was one thing. Give the continuous growth rate, and then they want us to graph each function. All right, I don't really know how to graph it in this A equals PERT format. All right, but we can change the format so that we do know how to graph. All right, we know how to graph when it's written in the form y equals a times b to the x. So we're basically going to do some rewriting here. All right, this p equals 5e to the 0.02t. I'm going to add some parentheses here. If we add parentheses there, it's the same function. All right, we do have an exponent raised to an exponent now. When you have that, you're allowed to multiply them together, you know, to get 0.02t. So same thing, you could split them up if you wanted to. All right, so if we split that up and then just type this part into our calculator, all right, we'd have p equals 5. We want to type that middle part into our calculator. That e to the 0.02, if you type that into your calculator, you get about 1.0202 if you round to 4 decimal places. That looks more like something that we can graph. All right, I know my letters are a tiny bit different, but it is in that form y equals a times b to the x. 5 would be our a, our y-intercept. All right, 1.0202 would be our b, since it's bigger than 1. That would tell us our graph is growing. And of course, we don't have a number on the end, so you could put a plus 0. All right, but there will be a horizontal asymptote at 0. So if we had to sketch a graph, we could do that. All right, we could put our horizontal asymptote in, all right, at y equals 0. And our y-intercept is at 5. And then it was growing, something like this. Again, we're just sketching a graph. Doesn't have to be perfect, but that's what it would look like. First question, they wanted the continuous growth rate. All right, again, this is in that form A equals PERT. I know it has a little bit different letters, but you know the R value would be the continuous growth rate. So our R value would be 0.3. If we change that to a percent, that would be 30% is our continuous growth rate. All right, so that was the first part of the question. And then they wanted us to graph it. All right, so to graph it, just like we did the last one, all right, I would add some parentheses in. All right, and then I would use a calculator to figure out what e to the 0.3 is. All right, if you type in e to the 0.3 in your calculator, get about 1.3499. All right, so 5, all right, think about if we're graphing this. Again, when we're graphing it, think in terms of y equals a times b to the x. I know our function has a little bit different letters, but A is the y-intercept. So 5 is our y-intercept. All right, 1.3499 is our B. B tells you growth or decay. So since this number is bigger than 1, you know we have growth. All right, and then there's no number added onto the end, so you could put a plus 0. So that would be your horizontal asymptote. All right, so now we could get to graphing it. Give yourself an x and a y axis. First thing I'd put in is the asymptote. Right, the asymptote is at y equals 0. Right, and your y-intercept is 5. All right, and then it's growing. Should look something like this. All right, we're truly just sketching a picture of the graph. Let's look at the last question, part C. This part in part C is to find the continuous growth rate. Again, when you hear that word continuous, think A equals PERT, even if the letters are a little bit different. Right, the continuous growth rate is R. Our R value in this case is that negative 0.2. So R is negative 0.2. Right? So think about what that means. Right? They asked for the continuous growth rate. Right? All of our continuous growth rates have been positive numbers so far. 0.02, 0.3. Right? Now we got a negative. Think about what a negative is. That's a decay rate. Right? Turn that to a percent. That means we have a 20% decay rate here. And again, we're talking about 20% continuous decay rate. Anytime we're dealing with this A equals PERT formula, right, you have a 20% continuous growth rate. So from here, we need to graph it. Right, so if we were to kind of just add some parentheses here around the e to the negative 0.2t, all right, we can then plug in our e to the negative 0.2, plug that part into our calculator. If you just plug in e to the negative 0.2, you get 0.8187. All right, so think about if you were graphing this, 5 would be your y-intercept. 0.8187, since that's between 0 and 1, that would be decay. And of course, there's no number added onto the end, so that would be a plus 0. That would be your horizontal asymptote. All right, so if we start to graph that, we could put the horizontal asymptote at 0. Again, asymptotes should always be dotted. They should always be labeled. All right, our y-intercept is 5. And then decaying means starting up high and decreasing as you go to the right. All right, so hopefully that should make sense that when you have that negative R value, that does mean decay. All right, I hope these notes make sense. If you have questions, contact your teacher. Otherwise, feel free to get started on the homework for tonight. Have a good day.